For question 35 from the homework, we're given the information that a constant volume calorimeter, a bomb calorimeter, was calibrated by performing a reaction where 5.23 kilojoules of heat was released during the course of that reaction. And that caused the calorimeter to raise the temperature 7.33 degrees. What is the heat capacity of the calorimeter? So we're looking for Q equals C delta T, where C is the heat capacity of this entire calorimeter. There is no mass component. Mass is already incorporated in this C because it encompasses all of the calorimeter. So for this calculation, we're given Q. Q is 5.23 kilojoules. I'm looking for the heat capacity of the calorimeter times my temperature change of 7.33 degrees Celsius. So to solve for the heat capacity of the calorimeter, I'm going to divide by 7.33 degrees Celsius, and we'll see that it cancels out on the right side. And that leaves me with a heat capacity of this calorimeter of approximately 0.7135, and for units, kilojoules per degree Celsius. For significant figures, I would report this answer to 3 significant figures based on the measurements given. So I would report this as 7.14 e to the negative 1 kilojoules per degree Celsius. That's the heat capacity of the calorimeter. Now, in the second calculation, we're told that we do a chemical reaction, a neutralization of HCl with sodium hydroxide. In the second reaction, the calorimeter increases the temperature of 2.46 degrees. We want to know what was the energy of this reaction. So again, we're going to use the same calculation. We're going to use Q equals C delta T, except for now my unknown is Q. I know the heat capacity of the calorimeter. I found that in question 35. I know the delta T. They tell us the delta T in question 36. Now I'm looking for the heat of this reaction, and that's going to equal the heat capacity of the calorimeter, so 0.7135 kilojoules per degree Celsius, times my temperature, 2.46 degrees C. When I multiply, temperature cancels out, and I'm left with Q in joules, or kilojoules in this case, which is good because Q should always be my heat. So I multiply 0.7135 by 2.46, and I get an answer of approximately 1.755 kilojoules. Again, I want to report this number to 3 significant figures based on the temperature measurement in the calculation. So to 3 significant figures, Q would be 1.76 kilojoules, or 1.76 e to the 0 kilojoules. 3 significant figures and scientific notation. Many questions like this came up in class of how do I differentiate specific heat with heat capacity. Heat capacity is just this. It's the heat capacity of the entire calorimeter. There is no mass component. This is encompassing all of the calorimeter. My specific heat, I would have to know a mass because my specific heat is the energy per gram times degrees Celsius, right? Per gram per degree Celsius. I have no mass component in either one of these calculations, and because of that, I can't do a specific heat calculation, but I can do a heat capacity calculation.